to solve an inequality, polynomial inequality, we're going to move everything to one side. So I'll move everything to the left here. 2x squared plus x minus 3. And we want to find the zeros of this now. We're gonna factor this. And this factors as a 2x and an x. And then we're going to have a minus 1 and a plus 3 here. And so we want that less than or equal to 0. And we set each of these factors equal to 0. We're going to get x equals a negative 3/2, and we're going to get x equals 1. And we're going to plot these on a number line. And so I've got negative 3/2 and 1. And we're going to, this separates our number line into 3 different regions. And I need to find the sign on each of these regions. And there's actually a pretty fast way to do this. We can plug just one number in, or we can actually use the leading coefficient of our polynomial. We know that if the leading coefficient of a polynomial is positive, that the right side, the far right side of the graph will be going up. So this is positive, and so the far right side will be going up, so it's going to be positive. And then we can use the fact that we know if the multiplicity of a 0 is odd, that the graph will cross the axis, and if it's even, it will just touch the axis but turn around. And each of these has a multiplicity of 1, which is odd, meaning that from the right side here, as I come to the 0 at 1, it's going to cross the axis, so it's going to become negative. And then from there, as it crosses at negative 3/2, it actually crosses the axis, so it's going to become positive. And now I'm just looking for when my polynomial is less than or equal to 0. So that's the negative values, and we're going to go ahead and include those endpoints because we want to include when it equals 0. So there's our solution to that inequality. Let's look at this second one here. Move everything to one side. You get x squared minus 2x plus 1 less than or equal to 0. And this factors as simply x minus 1 squared less than or equal to 0. So this has a single 0 of x equals 1, and that has a multiplicity of 1. Or sorry, 2. Definitely 2, because that exponent is 2. And now if we plot that on the number line, okay, x equals 1, there's 2 regions here to look at. The far right region I can determine using my leading coefficient. The leading coefficient here is a positive 1, so the far right will be a positive number. And the multiplicity of 1, the 0, 1, is 2, meaning we know our graph is going to kind of behave like a parabola there. It's just going to touch the axis and turn around. And that means that it's going to stay positive on this side. Well, I want to know when my polynomial is less than or equal to 0, meaning I am looking for negatives. And I don't have any negatives here. However, I do also want to include when this is equal to 0, and it does occur there at 1. So I can write that in 2 ways. I can just say x equals 1 is my solution, or we can actually do interval notation, but the interval notation is kind of strange because a single point all by itself in interval notation, we actually put in a curly brace. 1, close the curly brace.